All right, just one more fun one where we're finding area between polar functions. The blue one, or the bigger circle-ish looking shape, is the 2 plus sine, and the red one is the 3 times sine. And we're supposed to find the area in between. So you basically just need to find the area of the blue one, and then the area of the red one, and then subtract them. But first, I need to find the limits. And to do that, it's best that I use a good old-fashioned TI-84. So let me just switch to the live cam. And there's the functions. And then go to graph them and watch what happens. So there they go. They meet at the top. And then here comes the important part. The red function is finished, and then it's going to draw itself a second time. While the blue function is taking its time, the red function has nothing better to do than just go around in circles. And finally, at 2 pi, the blue function is finished. So it turns out we have to use different limits. So we can't just use one integral. We're going to have to do we get to do 2 integrals. So it did take the blue function all the way from 0 to 2 pi to complete the whole graph. And while it was doing that, the red one drew itself twice. So that means that this one goes from 0 to pi. Another way you can do that is say, well, right here is when r equals 0, and then it's going to go around until r equals 0 again. So if you put r equals 0, it basically says, when does the sine function equal 0? And if you just go back to the basic graph of sine, the first 2 times it equals 0 are 0 and pi. And if you go out to 2 pi, it's going to draw itself a second time. So we just need 0 to pi. All right, then we need to do the 2 integrals. So I'm going to do the blue one first, and that's going to be the bigger answer. And then the red one will be a smaller answer, and then subtract those 2. So for the blue one, I need to integrate. I think I'll start down here. I need to integrate from 0 to 2 pi. And then the formula is 1/2, which I'll factor out. And then the r gets squared. And then we need to do some algebra and square this binomial. So square this 2 plus sine of theta. So that's going to be a 2 squared is 4. Then multiply the 2 terms and double that. So that would be 4 sine of theta. And then square the sine. And when I said square the sine, you probably said, oh, a trig identity's coming, I know it. So the trig identity, in order to integrate sine squared, is 1 minus cosine of 2x over 2. So use that identity for this sine squared. And I'm not going to do anything else. I'll just recopy the rest in this beautiful handwriting and then replace the sine squared. So it gets replaced with 1 minus cosine of 2 theta over 2. And now we're ready to do antiderivatives. So the antiderivative of the 4 is going to be 4 theta. The antiderivative of sine is negative cosine, so that needs to be negative 4 cosine of theta. And then I would view this one as 2 fractions, one that says 1 over 2. So the antiderivative of 1 over 2 will be 1/2 theta. And then look at it as the other fraction, which says you have the cosine function over 2. So the antiderivative of that will be, well, just bring down the negative sign. The antiderivative of cosine is sine of 2 theta. And then because of the chain rule, we need to divide by an extra 2. And since there was already a 2 there, there's now 2 2's, or 4. And then evaluate from 0 to 2 pi. So let's see, there's the 1/2, there's 4 times 2 pi, there's minus 4 cosine of 2 pi, there is a half of 2 pi, and then finally minus sine of 2 theta, so 2 times 2 pi. And then that part's divided by 4. And then we need to say minus when you substitute the 0. But when you substitute the 0, that would be 4 times 0. This would be 1/2 times 0. And this would be sine of 0. So when you substitute the 0, all of these are gone. All that's left is this one, which is cosine of 0. And cosine of 0 equals 1. So it's going to be a -4 times a 1. All right. Then let's start simplifying. Well, right here we have a cosine of 2 theta, which means that that is going to be 1 times -4. And then that -4 and this +4 are going to cancel. So those are gone. And I can see that over on the right side, this is saying sine of 4 pi. So that's 0, so that's gone. My goodness, I did all of this work and all these things are just canceling. Okay, so what's left? There's the 1/2, that hasn't gone anywhere. There is an 8 pi. And when I reduce, there's also plus another pi. So in grand total, there's 9 pi's divided by 2. All right, we're halfway done. So that was for the 2 plus sine function. Now we need to do the other one, and we should get a smaller answer and then subtract. So then we need to integrate from 0 to pi the 3 sine theta. So then integrate from 0 to pi. The formula is 1/2, and then 3 sine theta gets squared. And let's see, 3 squared will be 9, so I'll factor that out. And then what's going to be left is our good old friend sine squared. And once again, sine squared needs to be replaced with 1 minus cosine of 2 theta over 2. And I think I'll go ahead and factor out that 2, so it now becomes 9/4. And after I do that, the antiderivative of 1 is theta. And the antiderivative of cosine is sine. But once again, because of the chain rule, I have to divide by an extra 2, which now means this is divided by 4. And we're evaluating from 0 to pi. So we have 9/4, and then pi minus sine of 2 pi over 4. Minus, well, when you use 0, the theta becomes a 0, and then there would be minus a sine of 2 times 0, so sine of 0, aka sino. And then there's still cancellation, because sine of 2 pi is going to be 0, 0 is going to be 0, sine of 0 is going to be 0, so all that's left is the pi, and then the 9/4 times that. So instead of 9/2, which we got the first time, we got 9/4. So now we finally just need to subtract them. So what is 9/2 minus 9 pi halves minus 9 pi fourths? So then just get you like a blue pen, and that allows you to get a common denominator. And thus we end up with 18 pi over 4 minus 9 pi over 4, which is a grand total of 9 pi over 4.